We good to go? Sweet. All right, so hi everyone, I'm Adrian. I guess I met most of you yesterday. Yeah, so I'm going to be taking over from Mark for a bit around more higher fidelity prototyping. So we're going to be looking at software prototyping with processing and open frameworks. We're going to be doing some hardware prototyping, like both just like raw electronics and moving into Arduino and stuff. And doing some physical prototyping as well, so 3D printing, that sort of stuff, with a gun maybe taking that part of the course we're yet to see. So can I just get a bit of background about you guys, like your programming experience, electronics experience, anything? So we'll start, and your names as well. Sorry, I don't know your names yet.
My name's
No?
Yeah.
Yep.
I was reading the book and I was implementing the examples.
Okay, cool. So that book there,
I have a PDF.
Okay, yeah. So I mean, basically what we'll be covering is mostly what's in the book, so probably a fair amount of revision for you, but that's all right. If I say anything wrong, feel free to correct me.
I'm John. Not so much programming, but
Okay, cool. And any electronics or anything, or?
yeah, just play around.
Cool. Richie?
Yeah.
Mhm.
I think I've just had a slide frozen and slide class, a small class in my course, which is 8086, like assembly level.
Oh, right.
Not much of that.
Okay. Arduino is a lot easier than assembly level stuff.
I'm Charles. My programming background's pretty lacking. I've done a little bit of HTML, CSS, JavaScript, and kind of come across just no Arduino or hardware or anything like that, or processing, but come across bits and pieces of other things like just MATLAB and things like that, which are kind of related. But
Sweet. Cool. All right. No, that's good to know. Some of this may be a bit basic for most of you, but bear with me. We'll get there. So yeah, let's flick through some of these because you've probably seen them before. So we're going to start looking at processing. So I know Mark's already talked to you about this a wee bit and showed you a little bit. So again, some of this may be sort of repeating because I wasn't here for his classes, so I don't know how far he's gone into it. But basically, so processing is a language which is based on Java, and it sort of is there to try and remove some of the difficulties in starting with Java. So just pull on the web page. So yeah, Java is predominantly an object-oriented language, but the problem is it kind of forces you to do object orientation, which makes it quite hard to get started with. And in fact, the computer science department at Canterbury used to teach Java as its first learning language. However, like that first hurdle of just understanding how to start a program in Java sort of was too much for a lot of people, and they ended up moving to Python because Python supports OO but doesn't force you to use it if you don't want to. So processing is sort of taking that same sort of approach in that, you know, the OO stuff is there. Do you guys know what object orientation is? Sorry, before yeah, everyone.
not better, but I'll look in time.
Oh yeah, I mean, but basically the idea is you have various ways of writing a program. So older languages predominantly used more of like a sort of sequential sort of thing. So you'd say, okay, computer, do this, and then do that, and then do this, and then do that, which, you know, it works. And to be honest, a lot of programs still have large chunks of that. Object orientation was moving away from that to the idea that you should write programs like with the structure of how things can be classified into an object. So rather than sort of saying, okay, well, let's do step 1, step 2, step 3, step 4, step 5. It's like, okay, well, let's look at this more abstractly. You know, let's say I'm trying to write a program to, you know, control, like do some home automation or something. You might have an object which represents a light switch, and it can have the property on or off. So instead of writing in my code, you know, switch light on, switch the light on, switch the light off, I'd have a light object, and I'd just say light turn on, light turn off. So that way you can sort of encapsulate abstract ideas into objects and then call those objects. And that way you can sort of, once you write an object, you can sort of put it away, and you don't need to worry about what's happening internal. All you need to know is how to interact with that object, so what methods to call and all that sort of stuff. Which sort of makes it like conceptually a lot easier to write programs, particularly quite complicated ones, because you can sort of abstract out ideas, write them once, and then not worry about them again. You can just basically say, oh, if I tell the light switch to turn on, it'll do everything it needs to turn itself on. But with Java and stuff like that, it sort of forces you to start with that, which can be quite complicated when you're just trying to learn the syntax and all these sorts of things. Yeah, so processing is basically a language based on Java, more or less is Java, which has been simplified to make it easier to write. Like you can just get in and start typing stuff, and it also comes with an IDE. So an IDE is an integrated development environment. So we go actually, and I encourage you guys to get your hands dirty with everything we cover in this course, because I don't have time to go through everything, so it's more just sort of point you guys in the right direction. So yeah, go to the processing page, hit download. You can choose to download and donate money if you want, but I'd recommend starting with no donation until you realize that it's worth paying some money to you. So, and then you download it, and basically you end up with a zip file, which you can unzip, and you get this folder here. And this is pretty much everything in processing. So you've got processing.exe, which is our IDE, our integrated development environment. And then it comes with a bunch of Java libraries and stuff to make life easier for us. So things to do with writing user interfaces, doing input-output, all that sort of stuff encapsulated in a nice, easy way. So this is the processing IDE. It's pretty basic. You type code in, and then you hit play, and stuff happens. So processing being primarily GUI-based, it always gives you a window that you can start drawing in. If any of you have ever tried to do anything with Java Swing or anything like that, you know how much of a pain GUI stuff is in processing. So that was in Java, sorry. So that was one of the main things they did with processing. So regardless of what I do, a window is going to pop up, even though I haven't asked it to, but that's all right. But you can see here, I've written a little bit of code, int x equals 0. So I create an integer called x, assign it to 0, and then I print it. And you can see down here, it's printed out the number 0. So not particularly exciting, but you can see that we can just start punching code in there, hit play, and it'll do some stuff. So we'll come back and we'll have a little bit more, some of the high level of the IDE a bit later. But yeah, so processing's open source. You can download the latest releases of processing and do stuff with them. Generally speaking, you won't have to unless you're really getting into some quite fancy stuff, which one of our master's students last time was doing. He was trying to get into some of the 3D graphic stuff, and they have their release version, which is basically as bug-free as they can get it, and then they have their newer releases with new, possibly untested features, and unfortunately he found a bug in the release version, so he had to download it and compile it, and it was a huge amount of drama. So try and avoid that wherever possible. It's cross-platform, so because it's built on Java, it runs on PC, Mac, Linux, or Windows, Mac, Linux. You can get it running on Android and I think iOS as well with a little bit of work. And it's a multimedia programming language. So Java can do all the stuff, itself. However, the more you get away from sort of the core part of programming, the harder it gets. You have to start importing libraries, and those libraries may have been written by different groups of people. You may have to use them in different ways and all that sort of stuff. Processing, they're trying to get this sort of overall encapsulated thing where you have everything you could possibly need. You have all your regular Java programming stuff. You can do 2D and 3D graphics. You can do sound. You can do video. You can do input. You can do output. And it's all sort of overseen by one group of people. So everything works in a similar way. If you know how to use one part of processing, you should be able to sort of pick up and start working with another part of processing without too much trouble. And it's very focused on multimedia. So it was designed for people who are predominantly non-programmers to write graphical and multimedia applications in. So I guess you guys have probably seen this before, but this is processing. So let's actually, we'll pop that window back up there, and let's actually have a go at writing some of these applications in the IDE and see how we go. Resize that a little bit so we can actually read it. So this is obviously quite a basic one. So let's just see, if I start with nothing and run that, I'm going to end up with a window and nothing else. So let's start doing something with that window. So Processing has a bunch of functions, which if we go to the processing website, and you'll see down the side, there's reference, tools, libraries, environment, tutorials, examples, etc., etc. But if we pop into the reference, we can see here are a bunch of the processing commands which are available to us to do various things, and they're all under various sort of headings, so structure, shape, 2D primitives and stuff. So that first command we have is size. Oop, been using a Mac too much. Size, which we can see under our environment. So this is all stuff to do with the window. So we can, or the window basic input output. So we can grab information about the cursor. We can find out what the frame rate the application's running at, and we can do things like size. So if we click on that, we'll see it's got a little example here. So size, which shows us how we can set up various window sizes, a bit of a description about how it all works, how it works with the 2D, 3D, and PDF environments, syntax, blah, 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 blah. So there's plenty of information about the various commands. And, you know, if in doubt, if you're trying to find a function, you don't know what it's called, it's usually a good idea to sort of come to the reference and just have a look through the headings and say, well, what am I trying to do? I'm trying to set the color. Okay, well, let's see, there's background clear, etc., etc. But let's start with the first example, and we'll go through it line by line and see how we go. So, God, I hate this keyboard. So size 512, 512. If we run that now, put a full stop rather than a comma. You can see now the window's slightly larger. So the default window, I think, is like maybe 256 by 256. I can't remember the exact number. But by setting the size, we can change the size of the window. So it's now 512 pixels by 512 pixels. Pretty easy. Then we can do background. 255. And if we run this, you'll see now the background's white. So you might be asking, why is 255 white? Well, most of the color functions have multiple different ways of calling them. So we could, if any of you guys have done anything with color, and it sounds like you probably all have, you know that you specify the red, the green, and the blue colors. So if I do background 255, 255, 255, we'll get the same thing. And now if I change one of these, we'll get a slightly different color. So basically all of the color things, they have sort of two different function prototypes you can call. So you can call one with just a single number, which will set all the values to that number. So if you want to do, you know, a black, a gray, or a white, you can just pass in that one color. Otherwise, you can specify the colors using the red, green, blue, which is probably more familiar to most people, and I think is probably a less confusing way of doing it, but it's not how these guys have chosen to do it. And then, so let's keep going. And if anyone has any questions at any point in time, please feel free to stop and ask. Try and make this as interactive as possible. So yeah, then I've skipped this full line just to do this rect. So you can see now we've got rect, and if we go back to here, and we're looking at our 2D primitives, you can see here we've got rect for rectangle, and basically that has the format, or multiple formats, so all these ones down here, but the one we've used is this one with 4 parameters, so A, B, C, and D. And if we look down here, we can see A is the X coordinate, B is the Y coordinate, C is the width, and D is the height. So this rectangle we've set at 150, 150, 150, 150 is 150 pixels across, or starts at 150 pixels across by 150 pixels down, and then it's 150 pixels wide by 150 pixels tall. So pretty straightforward. And it's just basically taking the default, what's known as the default stroke, which is the outline, and the default fill, which is clear. So the default stroke is black, a black single width line, and the default stroke is clear. Where are we? Processing. Right, so then if we do fill 255, 2550, we're basically changing the default fill. So now instead of being white, it's yellow. So now it's a yellow square with a black outline. And then we can do this last thing. 0, 50. So now if we run this one, you can see the fill, like this is yellow, so that's 255 red, 255 green, 0 blue is yellow, or it might be blue, green, red, I can't remember which way around they go, but you can find out. Oh no, it must be red, green, blue, because this is 255. So yeah, basically here we're drawing a yellow rectangle, and down here we draw an ellipse, and we set it to red. Now the only thing to keep in mind here is when we were defining our rectangle, we defined the top left point and then the width and the height. With the ellipse, we actually define the center point and then the major radius and the minor radius. So if I set one of these to slightly smaller, you'll see we end up with more of an ellipse and less of a circle, so it'll be squashed down slightly. So we basically said, okay, the ellipse should be 150 pixels wide, but only 100 pixels tall this time. Right, so that's all pretty simple. Everyone happy with that? Makes sense? Yep. So yeah, this is sort of beginner level. So this is just basically writing code, as I sort of said, without object orientation. So we just start punching in commands and I'll just execute them line by line. It's got no concept of objects or anything like that at this point in time. So this is getting a little bit more complicated now, and I won't bother typing this all in, but this is basically what it does. So this one follows the mouse around and it draws circles at each point where the mouse is at various sizes and stuff like that. So you can see now this is getting a little bit different. In this one we only had 6 lines of code and it just started at the beginning and ran through to the end. In this one now we have methods. So we have a setup method, a draw method, and a mouse move method. And these are actually methods which get called internally by processing if they're there. So I think if we... Yeah, so you can see in here there's a bunch of, so the methods in the reference API are the ones which have brackets around them. And so if we look at one of these, setup for example, the setup function is called once when the program starts. So there's actually, processing actually provides a bunch of functions which get called when various things happen which you don't need to tell it about. So if you, in our original code here, because there's no setup method, it's not going to call anything. It's just going to start running. However, if we did put a setup method, that would get called before any of our other code starts to run. And then you'll see there's another couple in here, draw. So draw happens every time that the operating system, so Windows or whatever, tells the window that it needs to redraw. So these are things, if the mouse moves over it, if the screen gets refreshed, if you resize the window, anything, this draw method will get called. And then there's the mouse move function as well, which gets called obviously whenever the mouse moves over the screen. Yeah, so we'll come back to some more of these complex examples today. We're just going to have a very brief sort of look at processing and introduction to programming. And then we can get more complicated again. So, you know, we started with just 6 lines of code which get called one after the other. Then we started with the notion of methods. So we have these methods which we can call or processing will call for us. And then we can go all the way up to object orientation. So this is, again, you know, coming to the idea of let's try and get these abstract ideas and put them into classes we can call, so we can write them once and then we don't have to worry about how they work internally anymore. So in here they've created, this is a thing which creates particle effects, and you can see here we've got this class called particle. So classes are basically a definition of an object, and this particle has a lifespan, it has an X and Y position, a change in X and Y. It's got its constructor which gets called whenever we create an instance of this class. So we create a new particle object, this will get called, and then update we can call manually ourselves. So yeah, you can go all the way from this really beginner sort of stuff, just writing a few lines of code which will just start doing stuff, to more intermediate, starting to make use of methods and functions, all the way up to writing quite complicated object-oriented programming. And processing, as I mentioned before, processing has its own IDE, which is this one here. So, you know, it offers most of the things you could want to do. You can open files, save them. It's got stuff about copy, paste. Copy as HTML is quite nice. So if you want to put your stuff on the web, you can copy, where are we? Copy as HTML. And, okay. Sometimes it packs a little sad, as it looks like it's doing now. As you can see down here, doesn't want to copy as HTML, unfortunately. But when it does work, basically it creates HTML with all the syntax highlighting. So when you paste it into the website, it'll have the right colors, and you know, things will be indented and everything, which is quite nice. Makes it a lot easier than just plain text to understand. do stuff like auto format, which will indent things automatically, find, run, and import libraries and stuff. So we'll talk a little bit more about libraries later on. And it's got some tools. So, for example, the color selector. So if I want to choose a nice color, I can just throw something in there, and then it'll basically tell me the red, green, blue that I can paste straight into my fill or whatever. So it's got a bunch of sort of nice things in there, but it is missing a lot of features. So have any of you guys worked with like Eclipse or Visual Studio or, yeah, a couple of you? So basically a lot of those things have things like autocomplete. So you start typing in the name of a function and then it'll pop up with a list of things. The processing default IDE doesn't have that, which I find incredibly tedious because I can never remember what the name of all the functions are. You can actually do it in Eclipse, and if you're planning on going really far with processing, it's probably worth eventually, looking at how we can get it into Eclipse. There is examples on here, I think, on the processing page. So processing in Eclipse, I'm not going to bother going into it in this class because we're not going to go into any detail, which is so much that you need to use Eclipse. But certainly, if you're planning on getting really into like writing large programs with processing, it might be something worth looking at. It's not that hard. I just can't bother doing it, to be honest. Right. So yeah, as I mentioned, it's a language of interaction. So it's got a lot of code and libraries around physical manipulation. So doing stuff with various sensors and devices and stuff like that. So if you look at the libraries, in fact, let's have a look at the libraries. You'll see there's the default libraries. These are the ones which get included by processing by default. But then there's all sorts of libraries to do various things. So if you want to do stuff in 3D, animation, data handling, GUIs, geometry, hardware. So say you want to use, you want to do some stuff in Android using the Android things. There's this Katai library which supports sensors, so GPS, accelerometers, cameras, multi-touch, networking, blah, 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 using the Leap Motion device. There's a couple of them, there's one of them in there. And there's also outside, these are just the official ones which processing decides to support. There's also open processing, which has more stuff on there as well. So, it's worth having a bit of a Google search and sort of seeing what resources are out there for processing. These ones are guaranteed to work and work well because basically the official processing group has, vetoed them. Open processing, you'll probably find a far wider range of stuff out there, but perhaps it might not work as well. It might crash. It might depend on various environments and stuff. But there's lots of stuff out there that people have already written, so you guys can sort of start from where other people have finished rather than having to rewrite everything. Start from reinventing the wheel. You can just start from building on top of what other people have done. And certainly that in this program, that's what you should be looking to do. You shouldn't be looking to create everything from scratch. You should be trying to pillage, steal, whatever, as much as you can, and then do that last 5% because that's where the interesting stuff goes. Nobody cares if you write another thing which has been done a million times already, but if you use what someone else has written to make something really cool, then that's what people are interested in. So yeah, physical manipulation, gesture, voice and speech, haptic, etc., etc. So open processing, we just looked at. So this is an open source community. And one of the cool things about open processing, which hopefully works now, they changed this a wee bit last time, and it stopped working on various browsers. All right, let's have a look. So basically, open processing allows people to upload their sketches. So sketches are basically programs written in processing. That's the terminology they use for them. And you can go into any one of them so you can look through and see what looks cool. So let's say this one here looks kind of neat. We can open it up and we can see the source code. So there's a source code in the background there. And what's kind of nice is because it's a Java-based language, it runs in the browser. So we can actually open up people's stuff and have a look at it. We can be like, oh yeah, this is really cool. I like this effect. It looks nice. So let me just go and steal their source code. Steal their source code, and with a little bit of luck, if I copy and paste that into my processing IDE, we can be like, wow, look at this cool thing I did, and show everyone, and people will be really impressed. But so open processing is like, it's sort of a great resource to go through. People have done anything you could hope to imagine. You'll probably find something on open processing that you can steal and then refactor for yourself. And also, I think it's a great way of learning how to program, because you can go in there, you can find something you like, and you can actually see how they've done it, and then you can start tinkering. And I think that's like one of the good ways to learn programming, is to look at how other people program. So you can go in here and say, okay, so this guy, when he was writing this one here, he's got a setup method. We know what the setup method does now. What's he done? He set the window to 400 by 400. He set the stroke, which is the outline of objects to this, and then he calls the key press method and blah, 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 and you can sort of go through it and see it. So I'd highly recommend, you guys, from now until the next lecture, download processing and install it or unzip it on your computer, have a bit of a play around, then jump on open processing and just have a look through, start stealing some things, try and do some other stuff. So, for example, with this one, it's in black and white. What would I have to do if I wanted to make it in color? And just try those sorts of things, get a feel for it. If you start getting lost or confused, jump back to the processing page and look through their reference library to try and understand what people are doing. Because we won't, unfortunately, have time to cover everything in processing. So there will be a fair amount of sort of self-discovery and self-learning. So as I mentioned, there's lots of libraries for handling various things. So the processing guys have a bunch that they provide for 3D animation, or that they've said, these are good libraries to use. But say you want to work with something. So say you want to work with a device. What have we got? Motion sensor, Arduino. Yeah, so say we want to do something for the Kinect. There's nothing for the Kinect listed on the open processing site. So there's lots of other ones. What's it called? toxiclibs.org. So there's lots of other groups who are putting together libraries for processing that you can just grab and throw in there. So this one is often a bit confusing, I find, to find what you're wanting, but let's have a look, see if we can find something in here. Okay, that wasn't particularly useful. But yeah, I mean, you can go down here and sort of look through the various libraries that they provide as well and sort of see. And again, they also have demos and downloads that you can grab the code of and have a look at and see what stuff is there. So I've changed bits and pieces, so have a look around the page, but certainly open processing is sort of a good resource to start with. So we've looked at these libraries which provide additional functionality on top of the default processing stuff. So let's just have a look at importing some of these libraries. So if we jump into processing now, let's start a new sketch. And say I want to do something with, let's have a look, what are the default ones? Something with minim. So minim's the processing's audio library. So all I have to do is go up to Sketch, import library minim, and it's basically imported all the stuff we need for it. So yeah, if you've ever used Java before, this should all look quite familiar. This is exactly the same way you import libraries in Java. You just say import, and then the name of it, so this one's ddf.minim, and then the various things you want to import, so SPI, signals, analysis, UGENs, and effects, and so on and so forth. And I think from memory, sketchbook, some examples. I think, yeah, so one of the good things I should have mentioned earlier, in the processing IDE comes with a bunch of examples. So if you go File Examples, you can see all the things down here. So you can look at the various topics. So say you want to do some GUI stuff, you can see buttons, handles, whatever. You can open those up, but we'll just stick with the libraries for the moment. So we have this minim one I just mentioned, which is for audio. So if we look in this, you can see there's a bunch of stuff in here. So let's look at Player File. And you can see here they've got their import statement to import the code from minim. Then they're doing some stuff, so we haven't actually looked at P3D yet. We'll look at that next week. But basically there's a few things, and they're all well commented usually as well. So we need to create a new minim object, load a file, and then call play. And then it's doing some visualization stuff in the draw method. So Let's try running this. The volume on this. So yeah, now we have some audio that, you know, if you have a look at this, basically to play this audio, you know, in Java this would probably be quite a large amount of work here. We've got import DDF minim, minim and audio player, and then we just create a minim object and call player load file. So we can actually probably get rid of, if we get rid of all this stuff down here, actually we'll just get rid of that whole function. So now if I run this again, oh, maybe I do need a draw method. Wait. Oh, play. Yeah. So now we basically have something which can play MP3s, and really if you look at it, we've got 1, 2, 3, 4, 5, 6 lines of code is all we need to play music in our application. So, you know, the whole idea is to take a lot of the burden off the program and make it nice and easy. Yeah, so all the libraries are stored in Java archives, so jar files. So if you want, you can actually, in fact, go into processing, and yeah, trying to remember where their libraries are stored. Well, okay. So I can't actually remember where they're stored, but these jar files, which is what all the libraries come in, they're actually just archive files like zips or whatever. So you can actually open them with WinRAR or whatever and have a look inside them. So you can see here, this is the one for the ant class, which I think is, I can't remember what it does, but it's something web-based, I think. But yeah, so if I could remember where the minim library was, you can actually have a look inside the minim, see what the classes, names and stuff are there, in there. To include them, you just import the code, and yeah, there's a few which come with it by default, but there's lots more to have a look around and have a play with. Yeah, so it's built on Java, so it's cross-platform, as I mentioned earlier, Linux, Mac, Windows. It runs on Android, and you can also get it running on iOS. And all right, we'll just finish up the last of this thing. So I know it's been a bit disjoint at the moment so far, but just trying to give you an overview of what processing is, give you a little bit of background, and then let you guys have a play with it over the weekend, and then next week we'll sort of start delving a bit more into the details. So we'll start with a bit of a programming refresher. So for you guys who are, you know, already good programmers, this should be incredibly basic, but that's all right. So in programming, there are a few things that you're going to want to know about. So one's variables. So variables are basically pieces or like things that you can store data in. So we can say we have a variable x and we want to set the value of x to be 1, y, and we'll set y to be 0.5. They can store different types of things. So ch could have the character x. So when we see a single quotation marks, it usually means it's a single character. And when we have double quotation marks like this, it means it's a string, so it's multiple characters. And basically, all these different variables here have different types. So these are some of the types which processing provides. So there's ints, which integers, so whole numbers can be positive, negative, or 0, but they can't have any decimals. Floats, which can be positive, 0, or negative, positive, 0, or negative, but they contain a floating point part, so they contain something after the decimal place. Char, which is a character, so a single character, so x, y, whatever. Strings, which contain a series of characters. Bools or booleans, which are a true or false value, so 1 or 0. And you can also have things which are signed versus unsigned. So signed means that it can be positive or negative, but it basically means you halve the number of numbers. So if you can store, say, 1,000 numbers and it's signed, it means that 500 of them will be negative, or 499 will be negative 0, then 500 positive. If it's unsigned, it means it goes from 0 to 500, but you can't go into the negative. So most of the time, you probably won't need to specify this. However, you may come across it in other people's code, so we'll just mention it now. So in case you see it, you can be like, okay, that's what that means. So let's just open up processing again and have a look at some examples. So why am I all the way down there? So this is another thing, another reason why you might choose to use Eclipse over the processing IDE. Sometimes it does weird stuff like that. So we can have int x equals 0 means that x will be 0, obviously, and if we print x, it will say 0. Pretty straightforward. If I do, you know, a negative number, it'll give me a negative number. So we're looking just down here in the, wow, that's really out of focus, huh? Yep. A bit better. Sort of, but not really. Yeah, so negative 1, if I try and put a decimal number in there or whatever, it'll tell me that it can't convert from float to int. What we can do, actually I'll come back to that in a minute. So say we want to store the number negative 1.1, I'd have to say, okay, that's a float, and now it'll store that stuff after the decimal place. So it's kind of good in that it warns us, you know, you're trying to store a float into an integer. I can't do that. So then we can do, let's do a character now. So character A equals A. And now C down here. So we have print something out, and print ln prints, and then puts a new line at the end so they don't appear right after each other. So now we have negative 1.1 and we have A. Again, if I try and put anything more than that inside of the things, it'll say expecting a character constant. So, you know, it's expecting a single character, but it's got multiple ones in there. If I wanted to do multiple ones, I'd have to put double quotes on it like that. But then it'll say cannot convert from string to character. So we have to say, okay, we'll make it a string instead. And then now it stores my string in there. Booleans. Actually, I think, yeah, so it's actually Boolean. Yeah, Boolean is true, so it can be true or false. I should make that print line. And signed versus unsigned, I've already sort of mentioned, but if we try and make that, actually I'm not even sure whether processing supports unsigned, but we'll look at it in open frameworks anyway. So yeah, so I mentioned before, let's say we have an integer y now, and we want to store the value of x. So x is 1.1, and let's say we want to store the value of 1.1 into our integer y. It'll say cannot convert from float to int. So it's not going to let us do that, but say we really want to do it for whatever reason, there's a technique known as casting where I can put the format of whatever I want, or the type I want it stored into, in brackets before the variable name, and it'll force it to stick it in that. Oops, and it helps if I actually print out at the end so I know what I've just done. So basically what I've done here is I've said, okay, yes, I know that x isn't an integer, but I want you to treat it as an integer, and Java will internally do some magic to do so. So you can see here, originally it was negative 1.1, and now we got the value negative 1 out of there. If I make that 1.5, it'll still be negative 1, because what it's actually doing is it's just chopping off everything after the decimal place. It's not actually rounding it or anything like that. So yeah, it's just something to keep in mind, that if you want to round it, I think you'll probably find there are, in here, the reference, there'll be something to round numbers off. Oop. Yeah, so calculation, there's a round function which takes a floating point number and rounds it to an integer. So it rounds it up if it's over 0.5, it rounds it, or 0.5 or more, rounds it down. But if we just want to cast it, we can just cast it like this. So we can basically specifically say, just be careful when you're casting, because if you try and cast from one data type to another, you'll crash your, which it's not supported, you'll crash your program. It'll do its best job to get you what you want, but it may not necessarily always be what you want. Right, So everyone happy with that? It's all pretty basic. Today will be. And we'll just look at maybe we'll finish we'll do the two slides after this and then we'll finish, I think. So the other thing is arrays. So say you have a bunch of data which is somehow related and you want to relate it all together. We can create what's known as an array. So this is basically the format of doing it in Java and processing everything. We define what sort of type it is. So this is an array which is going to hold some integers. And then we let it know it's an array by putting these square brackets afterwards. And then we can fill out our array by putting equals, and in squiggly brackets we put the values of the array. And X array, we can reference it like this. Let me just double check that it is correct. Yeah. So, we basically have created this array which in the first element of the array holds the value 1, the second holds the value 2, and the third holds the value 3. And so same thing up here. And then we print out the first element, so keeping in mind that computers usually reference 0 being the first element. So here we're saying print whatever is in index 0, so the first element of X array, which is 1, and you can sort of just make out down here the number 1. And if I make that, 2, it's going to say, any guesses? Yeah, 3. So it's going to go, if this is index 0, this is index 1, and this is index 2, it's going to print out what's in index 2, which is 3. Happy? Yeah? I know it's pretty boring, but it gets better, trust me, or hopefully. So operators, plus, minus, divide, times, modulo. We have people who come in with no programming background at all, so I know for you guys this is probably all recap, but it's worth it for them, and it's worth it for me to be able to keep track of whereabouts I am in my slides. So comparison, so this, we do 2 equals, so if we want to see so let's do int x equals 0, int y equals 1, let's say println x equals y. So a single equals like this is an assignment. So this basically says make x equal 0. A double equals is a comparison. So we're saying, is this equal to the other one? And in this case, we've said, is x, which is 0, equal to y, which is 1? False. 0 doesn't equal 1. Then we have not equals, which is the exclamation mark plus exclamation mark equals. So is 0 not equal to 1? True. Yes, it's not. And then less than, greater than, less than or equals to, greater than or equals to, and this is and or. So say we want to do 2 things now. A equal. So let's say we want to check to see that x is not the same as y and a is the same as b. So that's true now. So 0 does not equal 1, but 0 does equal 0. And if either of these things is false, then it'll be false. So both of them have to be true if it's an and. If I want to check to see whether either of them is true, I can use the 2 vertical lines, which is or. So if this is true or this is true, return true. And then there's the assignment operator. So I already said equals is an assignment operator. We set whatever's on the right-hand side to be on the left-hand side. We can also do things like, say, I want to increase the value of x. I can do x plus equals 1. And if I now do println x. So it started at 0, and then I added the value of 1 to it, so now it's 1. I can also do subtract equals, so take whatever's in x and subtract the value of 1 and then store it in there, so it's now -1. And then multiply equals, divide equals, and plus plus and minus minus, basically just add 1 or minus 1 off it. Hence why C became C++, because it's C incremented by 1. And the plus plus increments by 1. Cool stuff. All right. And we'll just, maybe we'll actually finish on this slide. And the final thing is control statements. So say we want to do some basic stuff. So x equals 0, y equals 1. and then we say we want to check to see if x is the same as y, we're going to print out the value same. If they're not the same, we'll print out different. So basically, in the if statement, we check to see if x compared to y is the same. If so, we run the first bit of code. If not, we jump into the else statement and run the second part. And obviously, that's going to say different because 0 doesn't equal 1. And same if they do. There's also the Elsif statement, so we could do something like this, else if x equals y. So now we check to see if x is less than y, we print out the value less. If it's the same as y, we print out same. Otherwise, if it's not less than or it's not equal to, then obviously it's greater than. And so if I run it at 0, it's going to say same. If I run it at x less than y, it's going to say less. And if x is greater than y, it's going to say greater than. And we'll just do the last one on the slide, and then we'll have a break, and hopefully your minds will be refreshed with programming. So we can do for statements as well. So for statements are a type of loop which basically allows us to run things a certain amount of times. So say we want to print out the word hello 5 times, we can say, okay, let's set a is less than 5, a plus plus. So this is basically how a for statement looks. It has 3 clauses within it. So the first one is our initialization clause. So this happens when we first reach the for loop. So in this case, we're setting the value of a to equal 0. The second one is the breaking clause. So this is when this clause is no longer true, it'll stop running. So as long as the value of a is less than 5, it's going to run whatever's in our for loop. And the last one is the increment clause. So what happens every time the loop runs. So in this case, we're going to print out, we're going to add 1 to a. So if we do now println a and run that, you'll see start at 0, so we set a to 0, and then we print a, so it's 0, and then we add 1 to a. And then we print a, it's 1, 2, 3, 4, and then we finally get to the point where a is no longer less than 5, and we exit out of the loop. We say, okay, we've reached the end of it. So we could also write that another way. So let's say int b equals 0, and we can do like a while loop. So we can say while b is less than 5. Oops. Println b plus plus. And now if I run that, 1, 2, 3, 4, or 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. So this while loop is the equivalent of this for loop up here. So depending on what you're doing, if you want to count something, a for loop is a good way to do it, or you want to do something a certain number of times, for loop's a good way of doing it. A while loop is typically more used for something which you may not know when it's going to end beforehand. So it might be something while the user is typing, do some stuff, or while this is happening, or while that's happening. We can also break out of a for loop. So say break out of a for or while loop. So let's just say we actually want to break out when a is equal to 3. We can do break. And so what this is going to do now is it's going to run through, but as soon as the value of a is equal to 3, it's going to break out of this loop. It's going to pop down into while, or down out of this loop and then start running. So now you see it only goes as far as 3 rather than 4. Right, and since that's 12, we'll end there. Again, sorry, it's been a bit of a slow, low-level sort of thing, but download processing over the weekend, jump onto open processing, have a look at some of the code which is on there, run it, try and understand it, and then we've got a little bit more of this refresher stuff next week. There's only a few slides left though, and then from there we'll start looking into some more in-depth and actually how to use processing to do something useful. If anyone has any questions, yeah.
What's really IDE?
Most IDEs which support Java, in fact, probably all IDEs almost which support Java, will support processing. So yeah, if you want to use something else, NetBeans or something, I'm sure there's instructions on the internet how to do it. Eclipse is just sort of one of the larger, more well-known open source IDEs. So. All right, cool.
So what are the negatives using processing? Like if you were building a simple kind of program,